Good day, everyone. Now we know that the site planning engineer for the hospital for the whole project is very important. And now we want to share you this training course that we can discuss about the site planning for medical imaging equipment such as MRI, CT, DR, and so on. And in this training course, we will know that how to design, how to choose, and how to communicate with our users, hospitals, and we can make sure all the project, we can make sure all the steps are very smooth and very clear. So this is our plan during this training course. So let's check our content. The way we have briefly speaking about our training course is the medical imaging system has a higher requirements for hospital sites. If omission occur during the site survey and planning, it may result in substandard image quality or difficulties in equipment installation and potentially causing some personal injury. That is why this course is very important. In our content, we are going to share the 6 points during this training, but we separate this by 2 parts, part 1 and part 2. This training is part 1. In part 1, we are going to discuss point 1, environmental requirements, point 2, building space and relative issues, and point 3, electrical requirements. The point 4, point 5, and point 6 we will discuss in our next training part 2. In the beginning, we are going to introduce the different source of interference. There are some main interference types, including vibration, ferromatic, and electromagnetic interference. The 3 types of interference are different sensitivity in different systems. For MRI system, it is sensitive to all 3 types of interference. In CT system, it is sensitive to vibration only because the gantry is rotating very fast, so it needs a stable ground. For DR system is the least sensitive, and it is minimum consideration needed in the site design. We only need to design the room space for the hospitals. Here I list some common interference sources, including parking lot, highways, subways, trains, water pumps, equipment with high power motors, air conditioning compressors, high voltage lines, transformers, large generator, large motors. And this within a 2-meter radius of magnetic center, we also need to pay attention to the reinforced concrete, which with mantle inside, sewers, and heating pipes. All this interference is what we need to pay attention in the site survey. If there is this kind of interference, we need to mark it and try to avoid it. So in the site selection, if possible, we should choose the site as far away as possible from all above source to ensure a final high quality installation images. Here, I list some of the samples which we said bad side case. In this case, the image quality after the installation will be interferenced by these issues. Let's see the first one. This MRI room, as the arrow shows, it is near the parking lots, and we can see there are many car parking. So the interference will come from the car engine start and stop. So during this procedure, the interference will come to the system, and finally it will influence the image quality, and we can see the granulars in the image. Let's check another bad case. Bad side case 2. Near railway or near subway. The interference comes from vibration and the big moving ferromagnetic item. As in the photo, that the big moving ferromagnetic item is actually the train. When the train passing by, the vibration and also the ferromagnetic signals will come to the MRI room. It will reduce the image quality. So this is also another bad side case. Here is another bad case. This case is due to the water pump. In this image, we can see the MRI room, as the arrow shows, red arrow shows, it nearby the neighborhood with water pump room. The interference will come from the vibration of the water pump, so the image quality is reduced. This is another bad side case. The MRI room near high voltage transformer. The interference comes from the high voltage electricity current, so the image also have some artifact. Above case we're talking about was the outer room interference, and there are some items in the room which may interference the image quality. Also, here we can see another bad side case. Is the MRI magnet just under the water pipes. In this case, the magnet will hard to get magnetic homogeneity. A poor homogeneity will get a poor image quality. So we should, when we check the in-room condition, we should avoid this kind of water pipe. And there is another bad case here. The in-room, this is actually the heat pipe. In China or in some other cold temperature countries, this item is very common, very popular in the room. This we call heat pipe. The heat water is moving in these pipes, and this pipe is also metal material, ferromagnetic. So if the MRI system is near these items, it will get also the poor magnet homogeneity. It will get a poor image quality finally. So during our site survey, we should avoid this type of items. Okay, after sharing some bad case, and we are now going to see how should we store the imaging systems like a CT or MR or DR when the system arrives hospital but before the installation. When system arrives hospital waiting for installation, it should be stored in below condition. The temperature is -5 to +55 degrees centigrade. The humidity is 10% to 85%. The atmospheric pressure is approximately 70 kPa to 106 kPa. And there is also storage node to avoid direct sunlight exposure. Also, there are the nodes that for permanent MRI system, due to the magnet stored in the gantry, its magnet may be suffer irreversible damage if it is stored above 50 degrees centigrade for long periods. So it is better to keep everything indoor. The system should be stored indoor and it is highly recommended. But for some hospital, for some sites, if they don't have enough indoor space to store, in this case, if there is no indoor condition, we can store the system temporarily outdoor. We can use a canvas shelter like the below images and set up a warning line to avoid the peoples come too nearby the MRI system. So this is also acceptable storage method. Okay, after we talking about the environmental requirement, the next part we are going to discuss about the building space. What is the in-room space and how shall we design the site? The building space we will talk in this part. Room size. For different systems, the room size is different, and also we list a table for you for reference, including a recommended room size, which means do not less than this size, and we list permanent MRI, including 0.3, 0.35, or 0.5 Tesla. We list superconducting MRI, include 1.5 Tesla or 3 Tesla. We list CT from 8 slides to 256 slides. We list DR, the dual column type. And generally speaking, the medical imaging systems need 2 rooms or 3 rooms. They are, first is the shading room. For MRI system, the shading room is made of copper or galvanized steel to avoid interference from outside. For CT and the DR, because they generate X-ray, so their shading room is actually made by lead. So the shading room requirement of the different systems is listed here. For permanent MI, it is smaller, compact design. So the shading room requirement is approximately 6 meter by 5 meter by 3 meter. For superconducting MI, due to the size is bigger, so the recommended size is 7 meter by 6 meter by 3.2 meter. For CT, no matter it's 8 slides, 64 slides, or even 256 slides, their room requirement is nearly the same. They are compact, the room size is approximately 6 meter by 5 meter by 3 meter. For DR dual column type, the room size is approximately 5 meter by 4 meter by 3 meter. So this is about their shading room. And there is an equipment room for MRI systems, but we can see in the line 2, the CT and the DR actually no need the special equipment room. That is because for MRI, the cabinet must be separate from the main unit, so it need a special equipment room from shading room. The equipment room is 3 meter by 2 meter by 2.2 meter for permanent. For superconducting is 6 meter by 2.5 meter by 2.5 meter. And all type of the systems still need an operator's room. the doctor, the operator will sit in this room to operate the system daily. So the size is according to their requirement. We recommend 2.5 meter by 2.5 meter. So that is enough. After the numbers, let's check the images to see how we design a room when we come to a hospital. For example, this is a total schematic drawing of a hospital. And firstly, we need to check which position we will place our systems. As in the red marked area, we can place all these systems. That is enough. And in this area, then we can place the MRI and the CT and the DR in the recommended size as in the red mark. This schematic, we can see that if we remember the last table, for MRI systems, we need at least 3 rooms. They are equipment room, shading room, and the doctor's room. From left to right, the equipment room, shading room, and the doctor's room is like this. And we place the cabinets in the rooms. In the equipment room, the MRI shading room, and operator's room, then we can check here. The equipment room, we place the cabinet. The shading room, we place the main system. The operator's room is actually for the doctor and operator and the radiologist. So they line like this. And there is a special case, special point for the permanent MRI. Because the permanent MRI, like the permanent MRI 0.5 Tesla, they are very heavy. The magnet weight is approximately 17 tons to 18 tons. So in this system, we must make sure there is a concrete plate, concrete